Okay, so this is another small tutorial for Lab 3 of Advanced GIS Spring 2024. And in this one, we're going to use a small subset of the Pleasant Creek Watershed, which runs through Capitol Reef National Park, near where UVU's field station is. So it kind of runs from up here in Pleasant Creek Meadow up on this boulder mountain. It runs down through these previously glaciated parts of the landscape down into the red rocks of the Colorado Plateau and meets the Fremont River near Highway 24. And so in this case, in this small tutorial, I'm just got a subset of the data, the LiDAR data that you're going to use, but I want to show you how to do ArcHydro tools on this small subset so it goes relatively quickly. So what I'll show you is instead of searching for the tools, I'll show you where they are located in. They're located in Spatial Analyst Toolbox, so Spatial Analyst Tools under Hydrology. And so whenever you have your DEM, so I have that here, I've color-coded it a little bit. And you're going to do hydrology tools. The way hydrology tools works is that it has to flow downstream and it doesn't consider pressure gradients in the flow. And so that means we can't have holes in our stream network or depressions that the water would have to flow over. And so we create what's called a fill DEM, where we fill any local basins that would be there that would impede that water from proceeding downstream. So that's your first step, is to fill your existing DEM. So I'd click fill. I'd input always the DEM surface, and then I would call it fill DEM, if I just simple. So I'd run that. That's our first step. So it shouldn't take very long on this computer. So there's my fill DEM. The next thing that you do after fill is it's not in alphabetical, well, it is in alphabetical order. It's not in the order that you do these processes. So after fill, we calculate the direction that if water falls on a pixel, what direction does it flow? That's called flow direction. So fill, number one, then flow direction, number two. And so here now we want to use our fill DEM, and we will output a flow direction of that fill. And basically what it's doing is making kind of like an aspect map. It's telling us what direction does this pixel flow to? What neighboring pixel does it flow to? So run that. This is a pretty fast process. And you can see it looks kind of like an aspect map. We have 8 values because there's 8 neighboring pixels that it could flow to. Okay, so after that, you do what's called a flow accumulation raster. And so you have to input your flow direction raster, and you have to make an output flow accumulation raster. So I'm going to call it flow accumulation. I don't like the flow that it gave. So flow accumulation, Pleasant Creek, I don't know. Maybe too long. And other than that, I'll go with the defaults. This is usually the longest process. Of course, this small area on my gaming computer didn't take long at all. Okay, so this looks like a big black blob. The reality is there's detail in here. What we need to do is go into symbology and change it from stretch to classify. And this worked fine for me, but you may run into an issue here. Actually, I have run into an issue. Never mind. Do you see it says failed to display the raster layer as classify? The reason that happened, so if I go back to stretch, is that it didn't build a statistical table for the data set. So we can go into catalog to solve that problem. And then we go into the folder we're working on and the geodatabase where these are going, and we go to the flow accumulation, and we would calculate statistics. that will then allow us to classify the data because it needs that statistical table to be built. Sometimes this is built by default, but if it's not showing up, just right-click on your data set, calculate statistics. Go with all the defaults here, say run. Okay, so now we can go back over here and we can change it to classify. And no, I'm starting to see rivers, so that's good. I would just say we want two classes, and one is river and one is not river. The one that's not river I'll call no color. The one that's river I'm going to call yellow because it'll stick out in this image. But then you have to decide what is the cutoff for a stream. Basically, how many pixels does it need if it's greater than that to be a stream? And here it says now that it has to have more than 627,000 pixels. That's probably way too many. I'm going to go to 10,000 pixels. Oh, no, I did that wrong. Oh, goodness. Sorry, I did this wrong. Let's go back to manual interval. And it's not happy with me. Okay, so I got to work on this. So go back to symbology. We need to have less classes. So I'm going to go, hopefully, to get it to allow me to change the number of classes again. So I go to manual interval. I kind of broke it here. Okay, so from 0 to 19,000, I'm going to say is no color. And then I'm going to remove these breaks. So I've forced it into allowing me to have these classes. And I'm going to change now my color to yellow. So there's my stream network, but I'm going to adjust this a bit. I'm saying above 19,000 is my stream network. Let's change this to let's try 15,000. Okay, so I do notice some issues. Oh no, that's perfect. Okay, it was a rendering issue. So this is a good representation of the landscape. And we can see that if I turn off this fill DEM and I just look at maybe the hillshade colors, maybe on top of the fill DEM. How about that? So we can see the yellow streams are kind of following where streams look to be in the landscape, and that's what we want. Because really what you're doing is you're tuning how many pixels in this landscape or how much area in this landscape does it take before a channel is initiated. And it might not work everywhere because there'll be differences in the water flow in different aspects of the terrain, like whether it's south or north facing slopes, etc. But this is just like a kind of an approximation, but it's definitely going to get us our major streams. And in some cases, maybe it's given me streams that I don't really want to be called streams. So if you're feeling like that, you can go back to the flow accumulation raster and you can say, let's tone that down. Maybe only want it 10,000 and above. Okay. But still, I'm still got most of the same ones. You could go even less, 5,000 and above. Oh, sorry, I'm actually going the wrong way. Let's go to 20,000, right? We need more area, so we'll have less streams. Yeah, so that's looking a little bit better, right, in this river terrace. So I don't really see a stream. So let's keep going that direction. Let's go to 25,000. Or we could even maybe try 30,000. It's not making a drastic difference. So in the end, I think I like this for this data set pretty well. So I'll stop with that. So I've tuned my flow accumulation raster data set. So if we go back here, we see, so we did fill, flow direction, flow accumulation. The next thing we can do is basically turn these streams into features. And right now, actually, I kind of need to make what we call a stream raster. And there's a number of ways to do this. But my favorite is actually not in here. I like to go outside of hydrology tools and I go to reclass, and then I do the tool reclassify, and I input the flow accumulation raster. It ports over my classifications that I've made, which is nice. And basically then I can say where it's less than 30,000 is now going to become no data. And then whatever is above that, I'll give a value. In this case, you can keep it as 2 or change it to 1, and we can just call this like river raster or something like that. Rivers raster. Run. And so that will basically reproduce this. So I can, and the value there are just the value of 2, which shows where those pixels, which would be classified as a river, are located. So then the next step would be go back to hydrology tools, and we can then go to stream to feature. And so our stream raster is the one I just created. And we tell it the flow direction raster, and then I'll make streams data set. So I can call it streams. It'll make a feature class, and we can simplify those polylines, sorry. Let's run that. Boom, look at that. It looks much better. We can now show things easily with blue. And since it's now a vector, not a raster, it's just going to look inherently better. So there's my river network along Pleasant Creek and the streams flowing into it. Great. Now what we want to do is create a watershed polygon. You're going to do this for all of Pleasant Creek, from where it meets the confluence of the Fremont River. And so there's this tool called Watershed. So if you click on it, it asks you to tell it the flow direction raster and a pour point data feature that basically is where the water's outflowing to, like the base level above which you want to calculate the watershed's area. It's going to produce a raster of that watershed, and we can then turn that into a polygon. So we need pour point data, and I'm not going to do it for the trunk stream of Pleasant Creek because, maybe that's a little bit boring since we don't really continue through here. So instead, I'm going to do one of these little tributaries and show you what that looks like. So I'll do this tributary right here. And so if I go to map and I select this line, basically I want that to be part of my watershed. Okay, so what I'm going to do is create a pour point feature, and I can do that right here. And you can do this in a number of ways. You can do it as a point, line, or polygon. Sometimes the points doesn't work very well, so I'm just going to try a polygon, basically make like a little outflow polygon. So I'm going to zoom in. I'm going to say that I want this, I want to know, this is my polygon. I want to know where the water comes into that thing. Invalid geometry type. Uh-oh. It's not happy with that polygon that I made, so let's remove that. Let's try again. I'll do it with a point. Let's show you what I do. So what you really need to make sure is that it snaps to the stream. But more than just snapping to the stream, it really has to snap to the flow accumulation raster. So if I turn that on, you want it to be snapped to the stream where it crosses that flow accumulation raster. So I clicked it there, and that should work. It may not, in which case we have a solution, which I'll show you after the fact. Okay, so then I can call this, we'll call this tributary watershed. And that's going to be a raster. So we'll run that and hope that it works. Zoom to layer. Where is it? It doesn't seem to be anywhere. That's great because it didn't work. Okay, so the next thing we're going to do is to make it work. So there's this tool which basically snaps that pour point, snap pour point. So we'll take that pour point data that I just made, and I'm going to make it snap to that flow accumulation raster, and it's going to make an output point pixel that is snapped to it. And I'm going to make sure that it snaps within 5 meters so that I don't miss it. Okay, so if I now zoom to that pour point, whoa, let's give it a color. Should be sitting here, right? Let's give it a discrete color. No. Classify. One class. Sorry, unique values. There we go. Okay, so the value is not showing up. Not sure this is going to work. Let's back up. Go to stretch. The values are really wonky. So I wonder what happened there. Let's remove that. So let's go back to geoprocessing. We're going to create a snap pour point. Pour point field is not integer value. Change it to object ID. That'll give us a integer. Okay. Let's run that again. Okay, so now there's my snap pour point. It is a value of 1. Zoom to layer. There it is. So that's weird, right? Because there was my um, pour point, but when I did snap pour point, it had to be this pixel nearby that can then work for calculating the watershed. It intersected that flow accumulation raster. Okay, so now we'll go back to geoprocessing, and we're going to create a watershed. We'll input the flow direction, and then we're going to use this snap pour point now and create, we'll call it tributary watershed 2 and run that. And boom, lo and behold, we've got our tributary watershed area defined. We went off the map, but I think that's a nice representation. And then what you can do is this. So you can go to conversion tools, and up here you can go, this is a raster, this watershed here. And so you can change that to a polygon by saying from raster to polygon. And we input that tributary watershed 2, and we call it now, we don't want it to say raster, we want it to say tributary watershed and say run. Oh, it failed. Why? We'll change it to object ID. Instead, try again. Oh, okay. It doesn't like the name. We'll call it tributary watershed. Run it again. Okay. Now, right, we have the watershed there. Here we have it again. But now it's a polygon, and that's nice because you can just make it a black outline, or maybe you want it to be outlined in blue, but then you could go to the feature layer and make it 50% transparent. And so that's kind of cool, right? You can see where that watershed tributary sits along the network. Okay, so clear. So then the other thing that I ask you to do is to create a river profile, and for the trunk stream. And so to do that, what you kind of need to do is select the trunk stream that you're interested in. And there's like interactive selection tools that you can use as well. So if I look at that, we can just add to current selection. So anything I click on will get added. Okay, we don't want this other thing. So I have to click over here and say remove from current selection. And then, so I've just got this trunk stream of this tributary watershed. Okay, and then, so I just had 2 segments. You'll have many segments, maybe hundreds. Then you would just right click, data, export features as tributary stream. Oh goodness, I did that wrong. So you right click on the streams, data export, and then stream export features. Okay, so I'm going to stop this tutorial here, and we'll do another one talking about basically how to then turn that into a profile.